Hello again, everybody. This is Randy from Programmer Zen. I hope everybody is doing well. Today we are going to discuss a very important topic. It's a topic of data structures. It is a very important topic not only for Swift UI but for any programming language. On a computer, data structures are everywhere. So we are going to learn what data structures are, and we're going to create one so you understand how it works. So let's get started. Before we start coding, let's do a brief overview of what exactly a data structure is. A data structure is a named set of finite data with methods that allow higher hierarchies to easily create and maintain the data. So you may have a big set of data, and what a data structure does is it allows an easy way to organize it and efficiently maintain it. And examples that everybody knows of a data structure is an array. An array is on pretty much every programming language. And there's also lists, strings, and stacks. We are going to discuss some more. And for each of these data structures, there has to be a way to manipulate the data, and that's called the methods. And a couple examples of a method is add, insert, delete, and sort. There are basically two types of data structures. There's a linear data structure. A linear data structure is a data structure in which data elements are arranged sequentially or linearly, where each element is attached to its previous and next adjacent element. Examples are an array, a stack, and a queue. And then there's nonlinear data structures, where elements are not placed sequentially. And examples of this is trees and graphs. We're going to basically concentrate on the linear data structures for this video. In another series, I will discuss the nonlinear data structures. So here's a high-level diagram of data structures. There's two types, linear and nonlinear. The nonlinear is tree and graph. I will address that in a future video, but right now for linear we have a static, which is an array, and for the dynamic data structures that are linear we have linked list, stack, and queue. In this video we are going to concentrate on the linked list, stack, and queue. And let's briefly define what each of these data structures are. We have an array where data is stored in contiguous memory and is referenced by an index. We have the linked list. Data is stored using nodes where each node points to the next node in the list. And there's a head pointer, references the first node in the list, and a tail pointer references the last node in the list. Then we have a stack. A stack is a linked list where a node is always added as the first element, and the first element is always a node that gets removed. And then there's a queue. It's a linked list where an element is always added to the end of the list, and the first element is always the one that gets removed. Now a stack is usually compared to a stack of plates at a buffet bar, where when you add plates onto the stack of plates, the last ones added are the first ones removed. So if you add a plate to the plate stack, when a person comes around, that plate is the first one that gets removed. A queue is usually compared to a line waiting to pay at the buffet bar. You get in the line, the first one in is the first one out, and on the stack, the last one in is the first one out. So a stack is called a LIFO, last in, first out. A queue is called a FIFO. The first one in is the first one out. So in this video, we're going to start with creating a linked list. And linked lists are so powerful and so easy to implement. And the benefits you get from using a linked list over an array is tremendous. So the way a linked list works is each element is a node. And a node contains a data element, which is usually either a class or just a simple data type, and a pointer to the next node. And here's a textbook diagram of what a linked list looks like. Right here, you have a node, and there's a variable called head that points to the very first node. So when you traverse a linked list, you always reference head, which will give you the first one, and then you go to the next, to the next, to the next until you find what you are looking for, or you run out of nodes, and the tail will keep track of the last node in the list. Now to show you how to insert and delete, which is surprisingly simple, to insert a node, what you do is you create a node, and then wherever you want to insert it, there's going to be a previous node and a next node. So what's going to happen is the previous node is going to point to the new node, and the new node is going to take the next pointer from the previous node, and that is done with just two statements. New node.next equals previous node.next, and the previous node.next equals new node. So in just two lines of code, you can insert into the linked list. And deleting is even easier. To delete a node, you just say previous node.next equals the deleted node.next. So now he's just going to go right around him, and the operating system's garbage collection and Swift UI will be in charge of deleting that data, so you don't even have to worry about it. So this is a high-level diagram. I want you guys to kind of get an idea of what we're going to do, because it won't make any sense if you don't have a good picture in your head of what exactly is going on. So let's get started implementing a linked list. All right, let's run a demo of this so we can see exactly what it is we're going to build. What we're going to do is we're going to implement a simple list utility where you can add to the beginning of the list, you can add to the end of the list, you can delete an item, or you can delete them all. So let's add Billy to the first, and now we're going to add, who don't we have, Anne, to the end of the list. And once this is implemented, basically what we got is we have an implementation of a linked list, and if you add first, that gives you a stack. A stack always adds to the first element of the list, and once you get add last implemented, we have the queue implemented, because the queue always adds to the end of the list. So once we're done, we're going to have everything necessary for us to build a linked list, a stack, and a queue. So let's get started. All right, so I got Xcode all fired up. Let's create a new project. It's going to be an app. I'm going to call it linked list demo. This is my organization identifier. You can use whatever you want. The bundle identifier is going to be your organization identifier, appending the product name to the end. The interface is going to be Swift UI. The language is going to be Swift, and none for the rest of them. I create mine in projects. You can put it wherever you want. We don't need a Git repository. Let's create it. All right, so here's the build project, the default, and on the right is what it needs to look like. So let's go ahead and get started. Let's get rid of the globe and the text hello world. So what we're going to do, the first thing we're going to do is up top, we're going to have a text box that says item list. Let's give it some padding, top 50 to get it off the top a little bit. And this needs to be in quotes. Let's give it a font. I want to be a system font, and it needs a foreground color of blue. All right, now we got that. Let's go ahead and add the spacer for it now, so we can bring it to the top. We need to have the string for the item list, so we're going to make two state variables. It's going to be items. Items, string, it's going to equal John, Joe, Amy, and that's enough for now, and we're going to go ahead and give it nil. Next, we're going to add the text field for the items. We're going to give it a font.title, and we're going to pad the bottom a little bit, and we're going to give it a foreground color of purple. Now we need to add the text input. So the first thing is we got to give it the label for add remove item. And we're going to give it a system 28 again and a color of blue. Now we need the text field. All right, there's the hint. And we're going to have to give it, that's going to be an item, so we're going to have to give it it's got a bind. So we got to give it a var up here of item. It's going to be a state variable, item string, and we want it to say Billy to match the right. So we got to give it some padding. We want that padding leading at 50. The text field style is going to be rounded border text. Field style. Let's give us a little bit of room here. Let's give this whole stack a background color right now, so I can, because that text box doesn't look very good, so I want to say dot background, and let's say color dot orange. Okay, and then we want to do, I just ignore safe area. And get rid of the padding. All right, now we got to give the text box a padding trailing. We're going to give that 50. And let's give it a padding on the bottom of, let's just do 10. Now we got to do our buttons. All right, so we got the add first. So we're going to do a button. And this action is going to be add first. And for the label, I want to make it a little fancy here. We're going to give it a border there. Now I see that was orange and I made the background orange. Let me change the background color a little bit. Instead of dot orange, I'm going to give it an RGB. I just looked up a good color. It's going to be 247, 213, 177. So that's going to be RGB. So it's going to be red. And you got to divide that by 255 because it wants something between 1 and 0. Red, RGB, green. It's supposed to be red, green. It's going to be 213 divided by 255. I need a period, I need a comma. And that one's going to be 177 for blue. There we go. And so for the label, we're going to give it 2 rounded rectangles. The outer one's going to be orange. And we're going to wrap this all in a Z stack because I'm going to have orange rounded rectangle, a green rounded rectangle, and add first all on top of each other. So let's give this a Z stack. It's going to be rounded rectangle. We're going to give it a corner radius of 20. And okay, we want the fill color to be orange. And then we're going to have another rounded rectangle. It's going to be fill color dot green. And we're going to have to give it padding so we see it. And we're going to give it a padding of 7. And then we're going to put this into a frame. And the width 255, and we're going to give it a height of, let's make it 75. And now we have to add the text. We want foreground color. We're going to make it dot white, and we got to give it a font to make it a little bigger. We're going to call it dot large title, and let's make it bold. So there we go. All right, so now that we got our button, we got to make 3 more. But before we do anything else, I want to refactor this a little bit. I want to turn this into what's known as a model view model architecture. And I will explain what that is as we go along. But the first thing I want to do is I want to create the folders for it. And the first one is a models folder. The next one's a view folder. And the next one is a view models folder. And then I'm going to also create a folder for our data structures. And the first thing I want to do is I want to move the content view into the view. Next, we have to create our view model. So let's go here. We're going to say new file from template. It's going to be just a Swift file. And it's going to be our view model. So I'm just going to call it view model. There is some naming conventions, but we won't worry about that for right now. So it's going to be a view model. And what we're going to do is we're going to declare a class called view model. And it's going to be what's called an observable object. And I will discuss that as we go. And what we're going to do is we're going to go to our content view and we're going to grab this up. We're going to grab these variables here. So we're going to move these to our view model. And instead of a state, they're going to be called what's published. And what a published variable does is if somebody derives a variable from this observable object, it's observable, then anytime a published variable gets updated, this model will notify it that the view needs to be updated, and that's how the view gets refreshed when data changes. So now we have, it's supposed to be nil. Doesn't really matter. So here's a string, here's our item string. So let's go back to our content view. And instead of items, we have to derive from that. So it's going to be at state object var. Actually, it's going to be private var. We're going to call it ViewModel equals ViewModel. Now we have derived now from our ViewModel, it is an observable object. So anytime a published variable gets updated, the content view will be notified to update its contents. So this is no longer items because we moved it to the ViewModel. It's going to be ViewModel.items, and this is going to be a bindable ViewModel.item. And there we go. Now it's working, but we have moved the variables to the ViewModel. Now all functions and any logic that has to do with this view, we're going to move to the ViewModel. The view is only presentation of the GUI, and any action that gets resolved, like clicking on a button, gets passed to the ViewModel. So now all we got left in the content view is to do the buttons. Now, your natural tendency to do, since they're all pretty much alike, is to take this button, copy it, and paste it 3 more times. But if you look closely, there's a lot of code here that we can reuse. And this is very important. You don't want to just cut and paste code that's alike several times in your application. So what I'm going to do is show you how to make a component out of this button. So what we're going to do is we're going to copy this button, we're going to make it a component, and then call that component, and it's going to make it considerably smaller. So we're going to copy it, and what we're going to do is in a ViewModel, we're going to create another view from a template. It's going to be a Swift UI view. And we're going to call it custom button. All right, so here in the body, what we're going to do is we're going to just paste that button. And if you look, the only difference between all of the buttons is one is the color, one is the text, and the other one is what's going to happen when you click on it. So what we're going to do is we're going to make these all variables. So we're going to make this text that says add first, which is the button description. We're going to call it title. And we're going to pass that in. So we're going to say let title string. We're going to pass that in, and that will now become the text. And then the other thing is the color. So we're going to call that color. And so we're going to say let color color. Right. And we're not going to. Okay, so it's going to be a color. And the last thing we're going to do is we're going to pass this in, and that is known as a tuple. So we're going to say let action. Looks like the auto-completion got it right, but what I got wrong is I did the wrong color here. This is going to be color.orange always. That's the outer border. And this is going to be color. And then the action is going to be added right here. We don't need to preview. This is just a control. You can do it if you want to. I'm not going to do it. So now let's go finish our buttons. Let's go back to content view. And what we're going to do is we're going to copy this button. ViewModel and remove. We're going to copy this button and the padding. Going to paste it. So now we've got 2 buttons, just so we get it to look right. We're going to say add last here, and this is going to be add last, and we're going to have to comment that out because we haven't implemented that yet. And so now what we're going to do, instead of button, it's going to be custom button. And we're going to have 2 parameters. It's going to be title, and it's going to be this. And it's going to be color. And it's going to be color.green. And here's the action, and the label now goes away. And there we have our custom button. See how much better that is? Let's open this up a little bit. basically 1, 2, 1, 2, 3 lines of code. So we're going to do that 2 more times. Custom button is going to be delete. And then we have the last one, ViewModel delete all. All right, we got add first, add last, delete, delete all, and is color.red. And delete is color.red. It's a destructive process, so you want to make them red. Okay, that finishes the content view. So now back to our view model. We're going to start implementing what we need to do here, and we're going to implement this as a linked list, of course. So we're going to say private var. I'm going to call it my linked list. Linked list string. We just got to do this. That's fine, that will get it. And then what we're going to do, this is a class, so what's it not liking? Oh, it's equals. Cannot find linked list. Oh, we haven't done that yet, so I'm going to comment that out. So, but it's going to have an init, and that's where we're going to make the strings. So we're going to say my linked list dot append element. That's what we're going to call it when we add something to the end. It's going to be an item. We're going to call it John. That's going to cause a problem because we don't have the linked list yet. But let's do a couple of these. Just like we did before, let's make John uppercase. And we'll do like we did before, Beth. We're going to do Amy. We'll do Joe. Steve. And why not Harry? All right, so now we're going to have to do, and we're going to comment these all out so we're not getting any errors. And then we're going to declare our functions. So we're going to have a public func. It's going to be add first. And we're going to have an add last. We're going to have a delete. And we're going to have a delete all. And we're going to have one more that's going to be called dump list. And what that's going to do is it's going to make the string that we see on the main screen up top, the item list. It's going to make a long string out of our linked list. And it's going to add it into the item list string, which is published. So when we update this, it's going to update the content view with our new linked list string. So this is going to be func dump list. All right, now I believe in our content view, we can uncomment all these. And let's see why it's complaining. It's going to be ViewModel. Probably got something spelled wrong. Okay, that one worked. And last, delete. Oh, I got the custom button in the view models. That should be, that's a view. View model. Oh, func. Okay, we're all good here. You guys probably caught that when I dumped it here, but it should be in the view. Actually, most people do a components folder and they put all their components in a components folder. I put it in the view folder because I want you guys to realize that it really is a view that you're dumping inside a view. Also, this dump list should be private. The delete all, the delete, the add last, add first, they're all called from the content view when you push a button. But this dump list is internal. you should add a private. It defaults to private, but I like to be explicit about it. All right, so let's see what we got. Let's go to the content view. It worked, so our content view is now done. Our view model will be done when we implement the linked list and call the functions here. So let's go create a linked list. So to start implementing our linked list, the first thing we're going to need is a model. So we're going to add a model. So we're going to get a new file from a template. It's going to be a Swift file. It's going to go into the models. I'm going to put it in the right spot. And it's going to be called node. And that's what we're going to use to implement our linked list. So node's going to be a class. I'm going to call it node. And we're going to have, or I'm going to call it element. Now notice how the autocomplete made this a T. What that is a generic. Now, what we're using throughout our whole view model is a string. So we're going to create a linked list of type string. So this node, we could say this is a string. But what that's going to do is it's going to limit our linked list to only support strings. What this generic does is, since we said it's a T, you can pass it whatever you pass in, it will get resolved based on what gets passed in here. So if you create a node and pass in a string, that node becomes a string. This element becomes a string. If you pass in an int, then it becomes an int. That's the basis for generics. Now, if we didn't do that, we'd have to have a linked list of strings, then we'd have to have another linked list of ints, and another linked list of floats, and you don't want to do that. So we're going to use generics here. That will make it so we only need one linked list, and it will get resolved. This node, it gets resolved when we create the linked list and pass in a string. Our linked list is going to say T, but when we pass in a string, that T becomes a string. So that's the basis of generics, and that's what we're going to do. So let's go ahead and finish this. We're going to have a next node. It's going to be var next. That's going to be of type T, and it's an optional because it may be nil, and we got to give it an init. So for the init, self.element equals element. That's correct. And self.next equals nil. So there's our node. So what it's going to do is when you create what's not like consecutive statements for our element, that's of type. So that's just T. So that's saying that's what we're going to pass in. We're going to say var element. We have a variable element, and it's going to be a string. And then the next node points to the whole node. So it's going to be a node T, and it's going to be an optional. And nil is spelled wrong. Let's get that right. So here we go. So when you create an element, the element part of it's going to be what you pass in. So when we pass in John, it's going to be John. And when we create the element, next is going to be nil. So if it's the first one, we're going to have head point to the node, and the next is going to be nil. And as we start adding and removing, we will resolve the next pointer. But here is our node class. All right, now we're ready to start implementing the linked list. So let's do that. So in our data structures, we want to new file from template. It's going to be a Swift file. And we are going to call it linked list. All right, so it's going to be a class. Of generic type, and you don't have to use T. I'm going to use X this time just to show that it's not necessary to use T. And yet, so we got a var node head. That's good. And we're also going to have a tail. And notice they're both optionals because they could be nil. And we're going to have, I'm calling it append element. And I'm going to pass in an item. And that's the way I have it implemented. They say new node. I'm going to say let end node equal. I'm going to get rid of all this. All right, let's start from scratch. We're going to say let end node equal. It's going to be a new node. And it's going to be element item. So that's going to create a new node from our class structure. And then we're going to, this is going to go to the end, so we're going to check to see if tail is null. So we're going to say if let end node equal tail, and that is correct. Else, that means we have an empty list. We're going to say head equals end node. And tail will always be assigned end node because it's getting added to the end. What do I got here? This is supposed to be an equal. And that's how you append an element to your linked list. Cannot find node. I believe my node's capitalized. And there we go. Very, very simple. All right, now let's briefly go over this, so make sure you understand it. The first thing we're going to do is we're going to create the node that we're going to append to the end. And then we're going to do this if let. What that is a test to see if it's nil. So if let end node equals tail, if it's not nil, that means we have a tail pointer. Tail always, the next is always nil. So what we're going to do is we're going to say tail at next is now the new node. And then right here, we're going to update tail so it points to the new node. And the tail at next is going to be nil because when we create the element, we set next to nil. So that new node is already pointing to nil. And if this is nil, that means it's an empty list. So we have to update head to point to the new node. Now head is pointing to the new node. And right here we're going to have tail pointing to the new node. So we have one node, both head and tail is pointing towards it. And the next is nil. And that's the way it works. Very, very simple. Next we're going to add an element to the front of the list. We're going to say func add element item X. Let's see what we get. Let end node equals node element item. That is correct. Node at next equals head. That is correct. Head equals end node. That's pretty good. I like the auto completion. That is correct. So what's going to happen is we're going to create a new node. That new node at next is going to point to head, which was the old first element in the list. So now what head is pointing to will be the second element in the list. We're going to update head to point to the new node. So now head points to the first element in the list. And yes, we want to test for tail. And it's going to say if tail is nil, that means we had an empty list. Then we're going to say tail equals end node. And in that case, both head and tail will point to the new node. So next we have the delete. And the first one I'm going to do is to delete all, because that's the easiest one. And then we'll do where we delete in the middle. So we're going to say function delete all. And it can't get any easier than this. You just say head equals nil and tail equals nil. Now you have an empty list. So next what we're going to do is we're going to do the delete add, which is probably the trickiest out of all of them, but it's not so bad. So we're going to go func delete element at. It's going to be index. So we're going to give it an index. So let's say we're going to delete the fifth element. So what we want to do is we want to traverse to the previous element. So we're going to traverse to the fourth element, and that's the element we're going to do all the manipulating on. But if it's the first element in the list, there isn't a previous element. So that's a special case. So we're going to do that one first. So we're going to say if index equals 0. What we're going to do is we're going to say head equals head dot next. So we're just going to increment it. So head now points to the second element, so the first element has no way of getting to it. So it's basically what's called a ghost element, but the garbage collector will clean it up. And then what we want to test is if head equals nil, that means it's an empty list now. So we have to say tail equals nil. And that's basically the first case if index equals 0. Now what we need to do is we need to traverse to index minus 1. Let's make sure that we return here when we're done so it doesn't fall through on our special case. All right, so now what we need to do is we're going to traverse to the previous node from the one we're going to delete. We need a node pointer so we can start traversing through the list. So we're going to say var c node equals head. So now c node is pointing to the very first one in the list. So we want to go to the previous one. So what we're going to do is we're going to say var index counter equals index. And then what we want to do is we want to say index counter minus equals 1. So instead of traversing to the one we want to delete, we're going to traverse to the one before that. And we do that by going while index counter is greater than 0, cnode equals cnode.next, index counter minus equals 1. That is correct. Cnode now is pointing to the previous node from the one we want to delete. And then I'm going to say if let next node equals cnode.next. All right, so what we have now is we have cnode pointing to the previous node, which we're calling previous node here, and next node is pointing here. So that is right here in this statement, the deleted node. So what we need to do is we need to say cnode, which is this one, .next equals next node .next, and that will delete that node. So we say cnode.next equals next node.next, and then we're going to say if cnode.next equals nil, that means that's the tail. So we're going to say tail equals cnode. All right, now the last thing we got to do for our linked list that somebody may need is we need to make it iterable. And what I mean by that is we need to let our ViewModel be able to use a for each loop and loop through each node. But in our case, we're going to just use a for loop. But what we need to do is we need to make the linked list conform to the sequence protocol. The way you make it conform is the first thing we have to do. There's one function called make iterator, and we have to define that, and it'll now become function make iterator, and it knows that. And I'm going to call it linked list iterator. And so what we're going to do is we're going to return a linked list iterator, and I'm going to call it start. And we're going to make a class called linked list iterator, and it's going to conform the iterator protocol, and I like what it's doing. So current node X, that's what I want to do. I want to init start node X self.current equals start. That's true. And I don't like this. And so what I want to do is I want to make a function next, which it's going to call. And I'm going to say let actual equal current. And then we're going to say current equals actual.next. And then we're going to return actual. And that's basically what we got to do. Now let me explain what's going on here. We're going to create an iterator, and the init function is going to have a start, and we're going to pass it in head. So the init, the start, initially is going to be head, and we're going to assign head to current. And current is going to be the next value that gets returned when the iterator function gets called for each for loop when it goes through the for each loop. So current now is going to point towards head. So when it calls next, it's going to say let actual equal current. The first time it's going to be head. Then we're going to increment it to the next one for the next time, and we're going to return actual. Pretty simple. So what we have to do is you got to make an iterator. The iterator is going to be this class. We're going to initialize it, the current to head, and every time it calls next, it's going to increment current to the next value until it becomes nil, and it'll quit calling it. And that will make it so we can use a for each loop in our ViewModel. All right, now that we got the linked list class done, let's go ahead and finish our ViewModel. First thing I want to do is I want to uncomment the linked list. I want to initialize it. And I just realized we can append all these, but until we use our dump list utility, we're not going to see it. Clean this up a little bit by going Shift Tab to indent it where it's supposed to be. Now what I want to do is I want to create, we're not going to need to initialize these items here anymore, although it wouldn't hurt. And we're going to initialize it there, and I want to do the dump list utility first, and we'll make sure all these append elements are working. So the dump list, what we're going to do is we're going to traverse through our list using a for statement, and we're going to append each item to the items string. And since the item string is a published variable, it'll automatically update the view. So the first thing I want to do, we're going to append item, is what we typed in on the front screen. If it's empty, we're going to return. So if it's not empty, we're going to go through the list and add everything. First, I'm going to create a result string. So I'm going to say for node in my linked list, and we're going to go through each node. And what we're going to do is we're going to say result plus equals, and we're going to add the element. So it's node.element. And we're going to add the pointer to the next node. And when that's all done, we're going to say items, which is the long string, equals result plus nil. And then we're going to clear out what we just typed in. What do I got here? If it's empty, return. Okay, let's run it and see if it works. That worked, but we lost our item here, and let's see why. All right, looking at the code, it looks like the very last thing I did was I cleared it when I dumped the list. So let's go ahead and we've got 4 functions to finish, and then we'll be done. So let's get started. So for add first, what we're going to do is we're going to check and make sure the list isn't empty, or the item. And if it is, we're going to return because there's nothing to do. We're going to say my list. We're adding, so it's to the front. So we're going to say dot add element. Now we'll add it to the beginning. We're going to dump the list so we see the update, and then we're going to clear the item. And that's all we really need to do. We need to check everything, and has no member add element. Let's add element. I think that's why I want to do add star. Let's see if it did any others. Append element, add element. I didn't catch that. Delete element. Okay, that should fix it. Let's go back there. Now for add last, it's just going to be the same thing, except for it's going to be append element. Delete's going to be a little tricky because we got to go find it. So we're going to do the delete all first. And so it's going to be all the same thing except for we're going to call delete all. Now to the delete, we got to go find the string that we're passing in. We have a syntax error here. Let's fix that. And delete all doesn't take a parameter. All right, so for delete, what we're going to do is we're going to go through the list. We're going to check each item, and if they match, we're going to call delete at from our linked list. First thing we want to do is we want to make sure that it's not empty, because if it is, there's nothing to do. And now what we want to do is we want to create an index to keep track of the index we're looking at. We're going to start with 0, and as we traverse through each node, we're going to increment index. So if the third index matches, we're going to call delete at 3. So let's go for node in my linked list. We're going to say if node.element equals item, then we're going to call my linked list dot delete element at, and it's going to be index. And then we're going to else, if it doesn't match, we're going to increment index. Now the reason we only do it if it doesn't match, because if the third element matches and we delete the third element, the fourth element now becomes the third element. So instead of us incrementing index, the index in the list automatically gets decremented. And that should do it for deletion. And then what we want to do is we want to dump the list, and we want to say item equals empty. And that should do it for our linked list. Okay, let's look at this real quick to see, make sure everything looks right. Add first, can't be empty. Add the element, dump the list. Add last, can't be empty. Append it, that's correct. Delete. We're going to go through each element. If it doesn't match, we increment. Otherwise, we delete the element at that index. That looks good. Delete all. Oh, delete all doesn't have an item. We don't want that. It's just delete all. And then dump list. We've already checked that. We know that works. All right. Let's run this and let's see if it works. Let's add Billy to first. Let's add Joe last. Let's delete Joe. And to make sure our tail looks good, we're going to add Jill to the end. Let's delete Beth. Oh, I got Amy spelled wrong. I'll fix that. That's not a big deal. So we had first, we had last. We did a delete. Let's delete all. And that didn't work. Let's see. Here it is, our dump list. The item was empty because delete all doesn't have any parameters. Let's get rid of this. And that should fix it. So that should do it for our linked list. In our next video, I'm going to create a stack and we are going to parse an arithmetic expression, and it's going to have the priorities and it should match what the calculator says on your calculator in any iOS system. And in the third video, we're going to make a GUI for this parser. We will have a calculator that is fully functional, very similar to what is on the iOS devices. So we will see you then in the third video. If you like this video, please hit subscribe to help support my channel and make sure you never miss an upcoming video.